All right. I actually used to watch Anton Petrov like every day for a while. Um like at least half a year. He puts out a new video every single day. Like a psychopath. I love it. It's great. You can learn so much from this guy. He's incredible. He's amazing. He's so smart. Um but yeah, I don't know, he's just great. Love his channel. So yeah, let's see. So it turns out solar system is the rarest planetary system out there. Let's check it out.
One of the more intriguing questions and one of the more intriguing mysteries in regards to the solar system is of course a question in regards to how normal is this? Is this a typical star system with many similar systems in existence around the galaxy? Or is the solar system entirely unusual and somewhat weird? And although for many decades a lot of different scientists, including the famous Carl Sagan, sort of implied that we do live in a somewhat typical, very common star system with nothing special around it, a lot of more recent studies, and especially the study we're going to be discussing today, suggest otherwise. They do suggest that the solar system is really unusual, very unusual, and potentially extremely unique. Hello wonderful person, this is Anton, and so today we're going to be discussing the question of how ordinary is the solar system. With a lot of this based on a study you can find in a description with the title Framework for the Architecture of Exoplanetary Systems. The mathematical framework that sort of works out what are the most common architectures for various star systems, and where exactly does the solar system fit in there. But the question here is, why exactly did scientists previously believe that the solar system was not unique and not unusual? Well, the answer here is really simple. They didn't actually have a lot of examples to work with, and we're mostly basing this on the idea of what we think is happening in other star systems, based on the observations of various stars. But the reality is that in the last couple of decades, the technology has advanced so much that we're now able to see a lot of different star systems out there, and even detect various planetary systems, where we can then analyze what sort of planets are formed there, and what sort of a star this is as well.
I have not checked out much that came out of the James Webb Telescope, by the way. I remember being so excited for the launch, and then it's like, all right, it's gonna take a little while for us to calibrate and get ready, and now it's been up there for a little while, and I haven't even looked into it for a while. We're gonna have to do that at some point. Do a deep dive into everything that the James Webb Telescope has seen that's like public, because it's gonna show us some incredible stuff. Oh, he probably will tell us. I really need to learn more about this stuff. It's so cool.
And so, because of the new advanced telescopes, we're now able to understand star systems much better than before. And it's really in the last decade, specifically following the initial discoveries from the Kepler telescope, which as you can see right here exploded right after 2014, when the scientists finally realized that a lot of these planets we're discovering are very different from anything in the solar system, and even those star systems seem to be very different. And so what exactly are those differences? Well, the biggest difference is that the majority of stars out there are usually binary. And some stars are even trinary or have higher multiplicities.
Wow.
But binary stars are the
That's
most
crazy.
common. And so the fact that the sun is alone is kind of already unusual.
That's neat.
Nevertheless, a few years back, NASA talked about this particular star system that about 3 years ago they believed to be the most similar in terms of structure to the solar system so far.
Oh.
So basically, out of thousands of star systems discovered, this one seemed to resemble solar system the most. This system is known as 55 Cancri. But even here, as you can see, it's not really that similar at all. Okay, it does have some kind of a gas giant, potentially somewhat similar to Jupiter, around the same distance, but the inner planets are very different. So here's what the inner structure of the star system kind of looks like.
Wow, they're very close.
But I guess more importantly, one of these inner planets is also a gas giant. One of the closer planets known as 55 Cancri b.
Is that a smaller sun?
And so here you have a
then?
mixture of gas
Or
giants
what?
and terrestrial planets, but also spaced out very differently to what we have in the solar system.
Yeah, we got
And even
lucky.
though the star itself is kind of similar, although this is technically an orange dwarf, also known as a K-type star,
Okay.
this is once again a binary system. And so if this is the most solar-like system discovered so far, you can imagine that everything else is even more unique and even more different. And as of today, approximately 900 various multiplanetary systems have been discovered so far, and not a single one has a similar structure to the solar system,
That's cool.
or even similar planets. So for example, the closest star system with a lot of different planets around it is the system we've discussed previously known as Tau Cetus. 6 different planets in orbit around this very intriguing star. But all of them are potentially terrestrial or maybe super-Earths, and the system does not seem to contain gas giants, at least none confirmed so far. And naturally there are also no ice giants like Neptune or Uranus. Likewise, another similar star system, known as L9859, was also discovered to contain several terrestrial planets, but once again very different from anything in the solar system. And this is despite the star being very similar to our Sun. With one of the most Sun-like stars, the star with a relatively challenging name, TYC 8998-760-1, containing 2 giant planets that are clearly visible, but also not really possessing any other planets that will be similar to planet Earth, even Neptune and Uranus. With the farthest multiplanetary system discovered, the one you see right here, this is at a distance of over 13,000 light years away from us, also containing predominantly gas giants, but in different locations and with different mass compared to the solar system.
Cool.
And more importantly, when it comes to the properties of various stars, such as mass and metallicity, there's really only a handful that's been discovered so far out of millions examined that seem to be Sun-like in terms of properties and in terms of age. So far, none have been discovered to contain similar planets. But
oh, sorry, a random factoid. Did you guys know that the gigantic storm, like the red spot on Jupiter, is disappearing? I think, if I remember correctly, that big red spot, which is basically a giant storm the size of 3 Earths, it might be gone in our lifetime. If I remember correctly. Correct me if I'm wrong in the comments below if I don't look it up, but I remember watching a video relatively it might have even been by Anton Petrov, honestly. I'm pretty sure it's shrinking significantly. And Jupiter might not have a big red spot by the time we're old fogies. Yeah. I don't know how long it's been going for. I don't even know if we do know. Mass for a planet to orbit. Yeah, there does need to be some. But also, remember, matter also sort of acts differently out in space than it does on Earth. Well, there's the thing, Keith. There are billions and billions and billions of people. It's alright if there's people focusing on Earth, and it's alright if there's people focusing on space. There are so many people that, like, there's enough people to focus on everything. Like, all the people that are interested in space it'd be wasted on having them worry about shit on Earth. They clearly don't care as much about, or they do, but they're more interested in space. There's like, what, 8 billion people? We don't all have to focus on Earth. I think it's very important to learn about space. Like, trust me, there are millions and millions of people working on Earth about Earth shit.
that's of course based on previous observations from previous studies and from previous data releases. Now,
stuff out in space can help us understand what's going on Earth. So there's also that, like the science, like cross-referencing different things. Like, it's a whole thing.
we have another study, mostly mathematical, that takes it even further. And here the main focus was architecture. What sort of star systems can form out there, and which ones would be the most common? And this is of course an important feature because we know that, for example, in a solar system, Jupiter's location and Jupiter's mass is very likely responsible for shaping everything else in a solar system, including potentially increasing or decreasing number of collisions everywhere else. And with 4 different gas giants on the outskirts, it's quite possible that the inner solar system is actually protected quite well.
Yeah, the gravity of them
things like water
takes a lot of the asteroids.
might have been the result of various collisions which could have been influenced by these gas giants.
Yeah.
And so the architecture here plays a pretty important role. And here, this was a mathematical model that tried to basically create various star systems and find out which ones would be the most likely and most common. Something that would be actually a very challenging task for the modern telescopes, but something that computers can do pretty easily. And even though the initial assumption years ago was that the solar system structure was not unusual, this study suggests otherwise. So first of all, the most common seems to be the one that you see right there. This is actually what TRAPPIST-1 system is like as well, and this is what the scientists have so far found in a lot of different star systems as well. Planets of similar size, usually not too far away from one another, and very often relatively close to the star. And it doesn't just apply to red dwarfs, it seems to apply to larger stars as well. Although for larger stars, they would not be terrestrial planets, but instead would be gas giants.
Not enough oxygen.
They also discovered that quite a lot of star systems were either mixed or even anti-ordered.
I'm not ready.
In other words, mixture of gas giants and terrestrial planets, like the ones I showed you previously, or even star systems where gas giants are the closest and terrestrial planets are somewhere on the outskirts. But obviously the biggest surprise was that the ordered star system, the one similar to the solar system, was the least common, with something like 1% of all star systems appearing ordered out of all of the ones they've created, which of course implies that the architecture we have in the solar system is super rare. But the question is, of course, why? Well, the simple answer is that it's pure luck. But in order to find the more complex answer, we have to briefly take a look at how stars form. It all obviously starts with a relatively large gas cloud that has to reach certain density in order to start forming stars. For example, in case of a nearby supernova, the pressure from the wave here is going to create just the right density in the gas cloud to then suddenly start forming various stars along the shock wave. This is pretty much what the scientists usually observe in famous nebula such as the Orion Nebula you see right here. And so inside of this cloud, various clumps start to collapse, creating various stars. But at first, a lot of these stars form what's known as trapezia,
rich people can
named
go to
after the famous trapezium cluster in the Orion Nebula. But this is not a true cluster because these are stars orbiting around one another. And so technically this is a multi-star system, but the orbits here are not super stable. And so eventually some of these stars are going to get kicked out, some of these stars will assume more permanent orbits in, for example, binary systems, and some of these stars might have some other fate. What happened?
Well, I imagine a binary system, it would be really hard for a lot of planets to orbit. So for those of you who don't know what a binary system is, it's when like two stars orbit each other. They kind of just like do this. Sometimes it's a little bit more elliptical. I imagine it would be really weird for planets to orbit that. Like, would they have like a really weird oblong orbit because the gravities are constantly shifting instead of the sun, which is just kind of in its, well, I mean, you know, the whole galaxy is spinning, but you know what I mean. Like, it's at the center and stuff orbits it. In a binary system, the suns are orbiting each other. The math behind that is, dare I say it, astronomical. All right, you can put me down now, but after this video. But I just imagine that a binary, like, it would be really hard. If there are a lot of binary star systems out there, then no wonder our solar system is so unique. Well, they get different, like, wavelengths, which kind of determine the different chemistry of the different stars or planets, you know, gas giants and whatnot. And so when they find out the chemistry of it, they can extrapolate a color from it because certain elements make certain colors, especially like, it's kind of like a similar thing, like when you think about it, like fireworks. Like fireworks are colored by different chemicals. Like copper will make it what, green, I think. Argon will make it, was it argon? Will make it blue. It's that sort of general thing. So if you look through these telescopes with a certain spectrum, I don't remember exactly which one, so I know I might be sounding like an idiot right now, but anybody who's smarter than me that knows what I'm talking about will know that I'm what I'm thinking. So when they take pictures or, like, you know, the long extended videos to get like an extrapolation of what a spot is like, the different wavelengths that are bounced back, they can extrapolate colors from that, so they can determine what elements they're made of, what percentages, how big they are, how hot they are, etc. And even then, in space, temperature is different than on Earth in a way. It's really out there, literally. No, they're not just making shit up. They're using this funky thing called science. It's very fascinating. I don't always remember all the right words for it. I try and learn a little bit about everything. It makes it hard to remember everything about everything. Either way, I think it's very fascinating.
Most of these stars, though, is obviously pure luck. So they all have a slightly different initial start. And that's of course on top of a lot of other activity, such as turbulent gas or a lot of whirling material that essentially interact with all of the material nearby, growing larger, forming planets, but also gravitationally pulling on one another and sometimes losing some planets because of gravity. But more importantly, they all essentially end up with very different initial conditions, and depending on the mass and metallicity, will also produce different planets with a different arrangement overall.
That's so cool.
Which is precisely what the scientists already can observe inside the trapezium cluster. And so because of this interaction, or technically even conflict between stars, when all of this is over and when they actually assume permanent stable orbits, or go on their merry way, they're going to end up with somewhat different final results. And on average, most of them will have similar planets, some of them will have mixed planets, quite a few of them will have planets in opposite order, and a very, very small fraction is going to have ordered planets like the solar system. Yeah. And so it's really the cloud that kind of decides everything. The molecular cloud and the interaction inside of it is going to produce very different star systems in the end.
That's cool as heck.
And so essentially all of this is just pure probability. But for some reason, the probability of having solar-like structure and of course solar-like planets is really exceptionally low. In their study, they actually list a few more reasons you can explore by yourself by looking at the link in the description, but in the end it's really all about the formation process and how, unusually, star systems like the solar system just do not form very often.
Yeah.
So a pretty cool discovery and definitely something to think about. But the question is, of course, does that actually answer the questions of life in the solar system?
True.
Well, that's not something we can connect just yet, especially because we haven't really found any signs of life around other planets or around other star systems.
Sucks.
Or really even right here in the solar system. So it's not something we can answer, and the speculation in this case, I guess that's just not my thing anymore. But we'll definitely talk more about this once there are more discoveries or more findings about this, or once the scientists actually do find a star system that's eerily like the solar system, like our home. On that note, thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description.
Oh, Wonderful Person t-shirt!
Bye-bye.
Oh, I love this man. He's so great. Oh my gosh. Oh, he's such a lovely individual. Man. Your boyfriend has that t-shirt? That's awesome. I love that. That is so cool. I should get one of those t-shirts. I love Anton Petrov. He's got such an awesome channel. Oh my gosh. That's true. There's so much science to remember. It's really hard to remember everything about everything. He is a true scientist. It's true. Yeah, Anton's awesome. I love him so much. He's great. He's such a good dude. And he's clearly got the support. Well, he uploads a new video every single day, the madman. He knows his shit, too. And also, thank you for the follow. He knows his shit, and that's why I watch him. He presents it very well. He uses pleasing graphics, you know, but the graphics actually make sense based on what he's talking about. It's not like a top 10 channel where they show like the wrong animal or something, you know. I don't know. He's just got a really, really good channel. I highly recommend all you guys subscribe to him. He's really good at putting shit together. And yeah, if you want to learn new stuff about space every single day, watch his channel. It's a lot to take in, though. It's so much, but it's so worth it. So good. Good stuff. Anyways, thank you very much, Anton, for putting knowledge out into the world.